This program looks at discontinuities in the first ionization energy. Below we have a graph of the first ionization energy of the first 20 elements. Let's begin by looking at a couple of general trends across a period. First off, as we go across a period, we can see generally an increase in the ionization energy. What I mean by that is if we go from lithium to neon, we see a general increase, and similarly from sodium to argon. This results from the greater number of protons that are in the nucleus at any given energy level. This results in greater pull and an increase in the ionization energy. What we're interested in are what are called discontinuities or breaks to the pattern, and we see those in a couple of places. First of all, we notice them here and again here, and we want to explore the reasons behind these. First off, let's look at the first gap between beryllium and the element boron. To gain an understanding of what's going on, let's look at their energy level diagrams. First of all, beryllium with its last electrons being placed in the 2s, and then boron with its last electron being placed in the 2p. The p orbitals are at a slightly higher energy level or more distance from the nucleus. That results in them being more easily removed. We can use a similar explanation here when we look at magnesium and aluminum. Here is magnesium's energy level diagram, and here is aluminum with the 3p. So that explains the discontinuity we see in these locations. Let's move on to the next location. So in the first pair, let's look at neon and oxygen. Again, the answer lies by looking at their energy level diagrams. Nitrogen has one electron in each of its p orbits. When we go to oxygen, I have to double up one of those p orbitals. The electrons in a doubly occupied p orbital experience some repulsion and as a result are more easily removed. This again happens over here with phosphorus and sulfur. Phosphorus with 3p orbitals singly occupied, and then with sulfur, the doubly occupied 3p orbital. I hope you found that useful. Thanks for watching.